The use of individual bits to store Boolean values is very common in C, but it can be quite clumsy. You've got to use those ampersands and or equals and tildes and all that in order to extract the information that you need. There's a much more user-friendly way of doing that, and that is by using fields of structures that are actually individual bits in size. In other words, you don't have to define a field in a structure that is an integer or a float or an array of characters or whatever. You can define the field of a structure that is a single bit, or 3 bits, or 12 bits, or whatever combination you like so. The second field in the structure there is a single bit. The :1 is the designator for single bit. If that read :2, then married would be 2 bits long. In other words, it could contain 0, 1, 2 or 3, 4 different combinations. 0, 1, 2 or 3. The fact that it is a single bit means it can only contain 0 or 1. In other words, 2 combinations, in other words, a Boolean. These fields are just treated as small integers. In other words, if you had a 2-bit field, like I just said, if married was a 2-bit field, then it would be an integer that could only be in the range of 0 to 3. It's a good idea to place all the bit fields that you have for a given structure next to each other, in other words contiguously. That way you minimize space inside a structure. You minimize how big the structure will be in memory. You get the least amount of wasted bits of data. If you don't know why that is, I'm not going to go into a discussion on structure packing now. It's quite an advanced and not particularly interesting topic, but just remember the golden rule. If you've got multiple bit fields in one structure, put them all next to each other. Put all their definitions next to each other. Let's go and have a look now at the employee example, rewritten, but this time using bit fields. This is bitfield.c, which is pretty much the same example that we just saw a moment ago, this time using bit fields. And here we have got a married bit, a manager bit, a male bit, and here's an example. You can have a 4-bit field, I might call it the number of kids that this person has, and how many possible kids could you have with 4 bits? Well, you could have a number in the range 0 to 15. In other words, you could have 16 different combinations, so that gives you a maximum of 15 kids. And as before, now the code is a lot simpler. This is just a Boolean now, so you can say, well, convert the answer to an uppercase, compare it with y, and if that is a y, uppercase or lowercase y, then this will get set to 1. And then to test it out, this is simply a Boolean now. If they're married, print out married, otherwise print out not married. It makes the code simpler. So if that's the thing you're trying to achieve, you're just trying to create a structure with several fields that are all individual Booleans, then to make your code a little bit more readable, you might want to use bit fields. Okay, that's pretty much all I want to say about bit fields. They're very, very simple. There's just like any other field of a structure, any other integer field of a structure, except they have a smaller range of values that they can take. Let's have a look now, that's the end of the chapter, at what exercises we have for this particular chapter.